Hello my friends and welcome back everybody. How was your day? How it's going? I'm all previous week I worked on the documentation, so I have to update all the docs regarding to the RoadRunner, you know. Let me check the stream. The stream is fine. Okay, so what we're going to do today, I'm sorry, tomorrow, no. So we stopped our implementation on the exec function. So basically, because exec function used read option method, which is not implemented yet in Rust library. So this is let me give you a little context here. So we worked on so we are currently working on a worker inside the RoadRunner, which we are like rewriting in Rust. And so today I implemented like a bare bones for all of this, like only a new create process, create worker process, and wait for the worker process and execute. So we like proved on the previous stream that we definitely can receive data from our pipes, and so today we're going to, I guess, bench a little bit our worker. So I'll try to compare our worker, like going worker versus Rust worker. And basically what so we don't have everything implemented in Rust yet. So basically we don't have we don't have execTTL, stop, kill, value, set, num_exec. So all of these functions we don't have implemented. So yeah, Rust might be, if they will be on a par. So keep in mind that we don't have everything implemented in Rust yet. So let me just pop out the chat here, and I put it here and then here. So I do like this styling window manager. So it's I'm not wasting a lot of space on my desktop, you know. So if, for example, I would have a Windows or some kind of GNOME distribution, so I would waste, I guess, a lot of a lot of space, a lot of like missed, I guess, spaces would be on my desktop. So T-Link window manager, I guess this is the best for the developer. So it's just my personal opinion, you know. So this, I don't need this anymore. I don't need this. I don't need documentation. So basically this is my work mess, you know. So this is documentation update. So as you may see here, this is the new structure of the documentation here, and you may see we are working a lot to provide a best user experience, especially with our documentation. So at the moment we don't need this. Boom, closed. And basically we need to let me check, where is it? It's not in pipe, it's in the frame, and we need this big method. So basically what's happening here, inside this option, inside this method, we are reading the options which might be in our frame. So as you see here in our like frame picture, so we have where is it, options here. So options basically have a variable len, so from 12 to 52 byte. So for example, if we don't have an options, so we have only a basic structure, so like a basic like 12 bytes. Thus it's why we are reading only 12 bytes when we receive a frame from a PHP worker, we are reading only 12 bytes at first, because we already know that it should be 12 bytes. So less value indicate a problem, and this would be like panicking. No, it's not panic, but error in going. And those were reading 12 bytes by default, and then when we parse our hidden length here, so we can determine what is actually what is the length of our header actually. So for example, here we might determine that, okay, so if it more than 3, then we can determine, okay, so we have an options, so we have to parse options. So options in our term is like words by 4 byte. So this 4 byte can represent like a small string, a number, like whatever you want basically. So we can encode, like when we collaborate between worker and RoadRunner, so we can encode here for example, divider between payload and actual header, so, or payload and a context, or like some data inside a payload. For example, as you may see here, (32) slice. So, oh yeah, we can return an option, basically an option of U32. Let's do this. None. So because our method basically can have can be like nil, so if we don't have an options actually, so in our case here, so if we return none, so we don't have any options. So we can basically, so this is, I don't know what is better here, so to return nil or none. So I guess nil here might represent also an issue, some kind of, you know. So for example, it could have so this clearly states that there are no options, but what is the reason that there are no options? So it's like error, or it's just some kind of like, I don't know, bad header here. So, and we can have a nil. In Rust, I guess it's much more clear here. So we have a none, so just none, no options. I don't know. So nil also fits nice here. So I don't know. Might be that these two approaches are the same. And let so let be like this for it hidden lane like in Go. Okay, so self read header lane OL here is options length. And if option length is less or equal than 3, you just return none. Boom, so don't have any options. Okay, so then we have to determine our actual options. So so what is the extent of these three like words? So to do this, we just I don't know, do I need to have this 12 like const last byte is equal to u8 and is equal to 12, like this. Last byte. So I do like this naming here in Rust actually. So this like uppercase with the underscores. I don't like this. So in Go, so basically Go forces you to this camel case. So for the like constants, I do prefer as a syntax when all uppercase with the underscore. Okay, so and option len is equal option length minus 3. So this is our actual yeah, and we also have to check if our options, so we have frame options max, yeah, is frame like this. So basically we also need to check if our options actually is more than our allowed option size. So if there are more options than we are allowed to have, in this case, I guess this is some kind of, I don't know, might be bad frame, or because we check this on both sides, like on the Go side, and also on our RoadRunner side as well. So I guess this is a clear reason to panic. Exactly with the same message like this. So so as you may see here, so panic actually is like the same as in Go, except of this exclamation mark. Okay, so next we have to, yeah, and also I don't know how it fit Rust, because if we allocate like this, so basically, so what is very nice thing in Rust versus like in Go here? So I guess a very little number of developers understand that this is a heap allocated variable. in any case. So even if we have very small options, so go have inside runtime have an optimization just to, if you have a small allocation of slice, it can be allocated locally on the stack here. So but here we have to return this slice, so here like this. And like what work Go did for you is like doing for you, it's like allocate this on a heap, so it escapes, it called like escape to heap. So it calls also escape analysis, like escape analysis going, like you can, so there are a lot of resources just to read, also an official one. So how it works, so escape analysis, so just to analyze how to determine some functions, some things inside the functions escape to heap. So and you can, like, you know, prevent this if you don't want to escape to heap, for example. And here, where's it? Yeah, and in this case this I know this is like no brain solution or no brain thing here, just okay, so I'm writing options make blah blah blah, so I'm going for further. But in Rust you are forced to understand that you basically can't allocate a thing and provide a reference to this thing as a return argument. So you can't do this because so value will be dropped after you exit from this read option function. So basically we can't do thing like this. Let's say let foo is equal to vector and sum foo like this. Oh, sorry. As we see here, boom, we immediately have an error. Can't return variable a value referencing to local variable foo. So we can't do this. So instead, can you do like this? Yeah, so also nice thing about Rust. So since we don't know the size of this U32, we can definitely do like this option box and return, like, for example, box from, I guess we can do like this now. Oh, I'm sorry, not box from, but sum and we should have an error only, yeah. So we can do like this. And basically this is what is a box. Box actually in Rust is things that you can like pin in on a heap, something like allocate something on a heap. Do we have a, yeah, do we have a nice explanation here? Okay, so but I wanted to, you know, to return, and do I need to have a deal with U32? Maybe it would be like enough to work with vector, just like this. But still, I think it's not possible, yeah. Oh, no, this is possible. So because we clone the thing. let me check. Vector. So as far as I understand, so vector under the hood uses like a slice or array. No difference. So I guess this is on a have the same performance. Yeah, so vector of vectors is a bad thing. But what if I want to return actually an U32? So we have Chat GPT. Okay, so how to return an reference to the array from the function in Rust. Please do not ask me to use a box. Oh yeah, so we can also have a lifetime. Yeah, so so what is this example for? So here we are using a lifetime of this input is the same as this output. So that means that this input not outlive this return argument. So, and that because it will work. But maybe we can do like this. Actually, to specify a lifetime, and here like
it explains your cocky attitude.
U32.
You can tell stuff like that from how my blood tastes?
So yeah, still no. Yeah, so this is clear for me that we can't return the local, but locally allocated, like for example here vector. But so even with the specifying a lifetime, but can we do something like this? No, we can't. Yeah, so this is so we are keeping fighting with Rust compiler. So we can clearly resolve this task with a box, but I don't want to allocate on a heap. So if I don't want to allocate on a heap, so I have two options. So provide an input argument, provide a reference with lifetime a to this function read options, like I'm doing often in Golang, for example, to not allocate a lot of slices, you know. So we just provide so to like to avoid a lot of copying in the memory. So when you are trying to return a slice from a function, for example, like this, you can provide a slice already in arguments in a function, and like do something performance critical here inside, and without returning anything actually. So I don't do this in Rust, but actually so in Go this clearly behaves like this option len clearly behaves like in Rust, like box of like, you know, of U32. So this is like clear for me. So this is like a box. Hello Yoma. So I don't know, lifetime will work if we specify it for input arguments. So we can so lifetime works if you have something already passed with the lifetime. So you have to do, like ChatGPT for example states, to have an input here with the lifetime a here, for example, like U32. And in this case you can return this input actually in this option, because this function will not outlive anything so allocated inside this function. So it will be allocated outside and destroyed when everything of all of this kind of incoming arguments will be destroyed. So basically this is fine, but I don't have anything like from outside. I don't want to behave like a I'm sorry, like a Go here, like to provide some kind of input. How can I input? Yeah, so also the reasons that I don't do I have an append function? No, I don't have. So, but I thought that we have append function in Rust. Append Rust. Oh yeah, so this works with the vector, I guess. Yeah, so push. Yeah. Do we have some kind of do we have an append to in Rust for slices? I guess we do. No. So yeah, extend from slice. Yeah, we know all of this. I guess that we have an append function. So I guess so. If no, okay. So basically, what options do we have here? How we can behave? We can return a vector. So yeah, we can solve this task. We can definitely solve this task with return a vector, just a vector here, so it will work for sure. But I just want to slightly think a little bit here. So if we return like this, it will definitely work. So as you may see here, so we can do like this because we will clone this. This is not a reference, so we've got a clone inside this function. So this is fine. But how we can stop writing? So it's like so extended question. I'm sorry, answer my little question. Yeah, so it's like endless result, and that's why we have like a stop generating response here. um, I guess ChatGPT is going to kill all the books because it's like I guess it just it can just copy and paste something from the book to you to read. So to not read everything in the book, if you like some kind of experienced programmer, for example. Yeah. And I don't know why. So if for the ChatGPT version 4, we only have like I don't know how much. Like yeah, 25 messages every 3 hours. So $20. I guess it's too costly to run GPT-4. I guess. So that's why for $20 you got only like 25 messages every 3 hours. Yeah. So in Go, this is fine. Like, so I'm even not thinking about this notation because it's actually allocated in a heap. But so in Rust, so I don't have any other options here in Go. Yeah, I can like pass an options from outside of this function here. So and do not allocate it in place. For example, this is a good option would be, but still we only have 40 bytes. It's not. It's not a big size, so it's limited to 40 bytes. So even if we call this function a million of times, it won't be like a big memory consumption point here. But in Rust, since we have an options, I want to have it slightly better, might be. Okay, ChatGPT. Can we return an array from a function in Rust without lifetimes? ChatGPT like every Indian developer. Yes, you can do this. Yes, you can do this. So on every, like basically every question, like, yes, you can do this. Yes, you can do this. But then you're pointing, but how? You can't do this. Yes. Oh yeah, for sure when we implement. So since we have an copy, yeah, so it's like, okay, so this is an array, and yeah, so array, I'm sorry, yeah, this is an array. So since array have a predefined a number of bytes here, just copying, so it just implements copy, and so I guess this is not a problem to do like this. So since it implements copy, I can do like this, for example. But then I have to fill everything with 0. Only 10 USD. So it's like, I don't know, for me it was 20. How can you get, how dare you how can you get ChatGPT for 10 USD? So it's like I shouldn't buy it on when they was released. How it can be 10 USD? Let me check. Yeah, 20 per month. Priority access to new features. Available when the demand is high. What is about slice? Yeah, I know that we can return a vector. Okay, so let's deal with actual vector here. And we should actually have like let mutable options of the vector, and vector would be here. It's like option len. Oh, it would be like 0 and option len, and option len should be as u size. Okay, so in this case we would have as much space here as we need to parse our options, and we can do our magic here. So let I is equal to u0 as u8, and then let g is equal to 0. And so we don't need this, so this is just boundary check elimination. I guess Rust is smart enough to determine that we just can't access. So Rust is, Go is just not as smart enough to determine that we have options and header here. I'm sorry, not options header, but we have enough length, and we don't need to check here to like bypass boundary check eliminations here. So yeah, and okay, so options and g is equal, yeah, so we have to end all of the thing like header, self header, last byte, last byte plus I, and all of this should be u32. So we have to deal with only so if we have more than 32 4 like we have basically more than 4 bytes, so we have to limit only to 4 bytes here. As yes, so header as u size actually, and here last byte, yeah, so this is oh, I'm sorry, so this is like in Go as u32 like this, and we also like, okay, so like this, and basically we should do this like 4 times, and plus I plus 1 plus 2 plus 3 and 8 and 16. So we have to shift all of the thing. Oh, no, I'm not correct. So we have to first is we have to use u32 because we can't shift u8 by like 16 bytes. I'm sorry, 16 bits. So because it only have not enough bits inside, and here is 24 and as u32. Okay, like this, and then we are returning options, and also So, oh yeah, we have to this mutable and this mutable. And this. And next, I plus equal to word, and j is plus equal to 1. So we just iterate in the next byte. And so do we have we don't have a go-to, so smart developers like, I'm sorry, what is go? Do we have go-to? Do we have go-to in Rust? Sure, I know this, how to replay this. So it's Rust should be like, you know, good programming language without shitty code with go-to, you know. So how we can we can actually, so this we can actually just return here. Why we don't need to return to use a go-to? I don't know. So if I is equal to option len times word, just return some options like this, and then and we have to repeat this like 10 times, all of this, and do not miss anything. Like this. So yeah, boom, return. So okay, so we have the last byte plus I fifths, and then like this. I don't know. So basically we have only maximum of 2 options at the moment. So we don't have even, we have 2 options only for the RPC. So that's it. So for all other things we have only 1 option. Yeah. And so this is this would be very easy to miss this in this calculations. So okay, so here is our like first is G, okay, and more than plus word if equal to word. Okay, this is 2. And basically we can just copy over the thing in just point 3, 4, 5. Yeah, so we can definitely use the same loop with 2 variables inside it, but inside Go this is kind of optimization to. So since we have go-to, compiler can clearly determine the number of operations and skip. So if we have like for loop, you have to check on every iteration if we like reached the end of the loop, if we have enough space in our header. So a lot of things compiler have to check for you. But when we unwinding the loop, especially in Go, first of all, we are pointing out to the compiler that okay, so you can skip your boundary check elimination checks because we did this for you, like here. So we already checked that header should be equal, the length of the header should be enough, like last byte plus I plus 3 to decode these options. So and we every time we check all of the things, so like proving to compilers that okay, we have enough space here, so you don't need to like use, for example, GNE assembly call. Where is it? So like jump, conditional jump, for example. Let me check where's my combo. So I guess I have somewhere like the whole assembly things. Yeah. Like jump, let's see the jump. So you don't need all of this kind of stuff here, all of these opcodes. You don't need to do this in compiler perspective, because compiler already knew that, okay, so user is smart enough, the user checked this for me. And since we have, I guess this optimization, I guess a far time ago from some kind of Golang sources, and I learned it from Golang runtime sources. So they also, when parsing the protobuf, they also did the same trick. So you can definitely, you won't have like, I don't know, 50% of improvement of your speed. So you'll get like, I don't know, 20%, for example. And but in this case, this is very important for us, because if we use, for example, RPC calls, and you have two options inside this RPC call, and user, for example, uses some kind of high performance applications, and user needs to have like very fast operations here. So we can't lose if we know that we can optimize this on the protocol side. So we just can't lose this 20% of performance, you know. And that because we are using this like unwinded loop with the Go tools. But in Rust, I don't think that we need to do the same. Mainly because in Rust we don't have a, I don't know, do we have boundary check nominations in Rust? Do we have bounds checks in Rust? I guess we do. So since yeah, so every programming language which have which have slices like doing some kind of bound checks. Here is example demonstrating bounce check in Rust. Would be very nice for ChatGPT to have not only copy but also run button, you know? So just imagine how it would be like awesome Arduino. So Rust exceptions written in Arduino. So if we would have like run buttons for code, so it's like it can, or for example, edit here. So if ChatGPT make a mistake, so we can already edit this code and hit the run button. So it would be, I don't know, I guess very nice. I don't think that we do need this in Rust, especially this loop unwinding optimization, but you know, why not? It not bother me a lot, like to have some kind of big functions. So we'll see. Actually, let me finish this, and we are going to compare the performance benefits, and we'll try to write this in a like regular loop. So because this can be easily written in loop. So we only have this I. So this is constant. Self header is constant. We have this like loop variable. They are basically the same every iteration, like 1, 2, and 3. And yeah, so only one thing that we have here, which is like changing on every iteration, is I. So basically, why it's changing? Because we have like continuous like amount of memory, so we have to check the memory by blocks of 4 bytes, like by these blocks. So those we need to multiply last byte is like 12, and plus the like addition to move this sliding window. Yeah, like sevenths. It's like I do like copy pasta. It's just I don't like. I don't need to write a loop. I do like a copy pasta here. 8. And it looks like very serious, you know, when you have such big function. It looks like, oh, this is a reason to write like this. Yeah, and in this case, this is the last byte, and we don't need to check. 8. Yeah, you're right. Thank you. You saved my life, actually. 10. Yeah. Thank you very much, Yama. Actually, we can write tests for this. Let me just write a test number with the magic name number 4, and let's do the trick. So here we are going to write ff write flux no, not flux, actually options. And let's do like this: 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do like this. And oh, this should panic here. If that's okay, panic should be error. Oh, should not be error, I guess. No, so I don't know why should be error here. Should not be an error. Let's do it better. CRC verification was failed. And like this. Okay, so at this point we have our frame and read frame. So actually we don't have here, we're just emulating our read frame from some kind of transport layer. We're allocating a new frame and reading the old one here, and in the res here, which is represented our return frame, we should have an options. And let me see these options. So first of all, yeah, we should have much like bigger, yeah. So as you may see here, this is our options. So starting from the byte number 12. So 10, 11, 12, 13, 14, 15, 16, until 18. Okay, so we definitely see an options. Next thing is to parse them. Read options. Unwrap. And oh, res is not mutable. Why it should be mutable? We are not actually mutating self. Just reading it. So why it should be? Okay, let's determine later. Yeah, and now we should have our slice with all of our options here. Boom. Yeah, so as we see here, everything parsed correctly. So we definitely have our options which we actually passed here. So it can be like numbers up to 4 bytes. So let's just make it a little bit more complicated, not only 2 digits per number. Why it should compile everything like from the beginning? So okay, fine. And let me add some kind of write payload. Let it be like our usual hello. Oh, expected vector. Oh, yeah. I don't want to change this function. Let me check what we do have. What we have inside. Here's like, yeah, EU8. Oh, yeah, B. So, yeah, I'm stupid, sorry. Just B, so we can use. Okay, so let me just write this payload just to check. Write CRC. So I'm doing this just to separate this option from a payload, just to see how it works actually. So might be it will work slightly different if we write a payload here. So with panic. Oh yeah, so definitely we have a panic here. And why? Oh, CRC verification failed. Why? Write flags, write payload, write options, write CRC. Yeah, so but you know, inside write function, write options, we definitely use just loop, just to like simplify. So maybe we should update our read options function as well. So why are you panicking here? So why the CRC verification was failed? Okay, what we have in 5, 6, 7, 8. So this is suspicious. We have 0, 1, because right, oh, 6. Yeah, 6, 7, 8, 9 bytes. So 1, 28. It's like suspicious to me. Like too small number here. And what we have. Missed the point. CRC, so yeah, we definitely would have a different value encoded in this year 32. Oh no, we have a okay. If yeah, so this is like inverse if let, you know. So if okay, we're panicking. If like if error, we should panic here. Yeah, but error should be of the Gorich. It's not like this. Error. We actually don't need this error here. But how it can be successful here? So if okay, I'm not writing CRC here or what? So we need to revisit this test. Yeah, this is much shorter. Okay, so this is just inverse if error, so everything is fine here. Nice. And options should be assert equal. Let me just do like this. And vector of these values. Double check. Fine. So nice. We implemented this function, and let me cargo. I know this got it, so every time I just point in my terminal, I have to point to JetBrains. And yeah, I know that you can like highlight my built-in functions. Cargo Clippy. Nice. And cargo FMT. Nice. So implement read options function. Boom. Okay, so next, since we already implemented this function, we have it here. Okay, so we can continue our SDK. After execution, so read flags, read options, and if options len is not equal to 1, we are... Oh, so this is options. Yeah. Match options. If none, so we are returning an error. This is not an IO error. I know what's type of. So let put us ours famous not an IO and return an IO error. But here our cause would be let's say, oh, we don't need to invent everything here, invent our error messages, so we already invented them. And for the sum, if options len is not equal to 1, so we are returning really the same error message. And oh, so we have to continue our like, let's say, parsing payload here inside this match. Do I want to have this inside match? So we also can have a thing like this, so we can just like check is none, for example, and return an error, and then if not none. So since we return an error here, we just unwrap later without any problems, because we already checked that it's not none. Okay, so let's do this in this branch. And we only need to check out. So we also should have a separator. So in our frame we have a payload and a context. So, and in this case we should have a separator between actual let me show you our node. So bright again. But where's our plan? We should follow our plan of re-implementing RoadRunner in Rust here. So well-designed plan, you know. So basically we should have so we're having this. So just imagine we are transferring something over the network. So here is the network. Boom. So we're transferring like sausage. Yeah, I know. Every time I just open it, like, oh, so bright, and my eyes went fine after a few seconds. Like, okay, I'll change it later. So every time. But yeah, so okay. Imagine we have some kind of frame. This is just some kind of sausage passing over the network, and in our frame we have two important things inside it. We have a payload. Payload is actual data sent by the user, by the PHP process. So, for example, it can be like a JSON, binary data, so anything that we should return to our user. And a context. Context can vary, so this can be various things, like a metadata, basically, and in different plugins it means different. So, for example, in terms of HTTP, context is a headers, basically headers. So do we need to return, for example, content encoding or payload length or anything like headers that we pass from the PHP to the end user should be in this context. And with this simple concept, we can just split our actual data from the context. But when you're receiving this sausage over the internet, you don't know where this border actually. So you don't need where is it. So what is this? Should be question mark. Boom. Perfect. So you actually don't know where is this splitter, divider, I don't know. So and we pathing the thing inside the options. So when you receive a frame, you also have an option how to decode this frame actually. This is like, for example, if you use a Gorich inside your team, for example, you can agreed inside your team how you can pass different things and options. But inside our team, we agreed that okay, so we developing this protocol, and we agreed that we are passing this divider inside the options, and we are passing the actual length. This. For example, 10 bytes. So, and we're getting 10 bytes, cutting from the payload and return as a payload, and just getting the rest and passing it as headers, for example, and a payload. So, this is actually how it works. And inside this function, so we just checking that we definitely should have this separator. If we don't have it, we just can't have a zero context here, because in every plugin we are passing at least headers. For example, for HTTP, at least one header should exist. So if we don't pass in anything, that means that we definitely have an error here. And I don't know, do we need this check though if the len of the option is less than a payload? So yeah, let's just mimic all of this go function. Okay, if frame receive len, payload length is less than options 0. Yeah, we should also convert it to expected to usize. Then we are returning not an IO error, so definitely we need to deal with our errors here, because this is you can see in Go this is much uglier, but I have a lot of type of errors like network error, soft job error, decode error, network here, and as one network. Inside Rust we have a IO error, but not an IO. And message would be a bad payload. And I don't want to return a payload because it can be such kind of, 4 gigabytes of bad payload. I don't want to log it. I have to delete this from Go as well, but yeah, I'll do this. And next thing that we have to form our payload. So if we can't just okay PLD like this. Oh, oops. And here we can just do like this. And only thing we need to do here, so inside the payload new function we have context and a body, and the only thing we need to do here is to pass our frame payload options 0 to and frame receive payload options. We have to convert to size this, sure. And yeah, so this would be body is and we have to also pass a flags. Where do we payload? Yeah, pub flags, no, codec, I'm sorry, codec is U8. So basically codec is a basically how to decode this payload actually. So how you have to decode this payload inside after you receive it. Like you don't need to. So actually I don't need to decode it like here in place. But if I want to return to some result to user, I have to decode this payload from the format in which it passed to me. Like for example, here I can have protobuf encoded payload, and I have to decode it on the receiver side. And so we should have a legs U8 and codec. Not flags actually, but codec. Yeah, I know that we can simplify this like this and like this. Okay, Clippy. I'm not against it. Okay, so I this is not correct. We have to do from UTF, yeah, like this, and self. So actually, we have. Do we need to have this? So I don't think that we should have this to string. Okay, frame flags, PHP, mode. Okay, and here we also should have an flags. Yeah, read flags. This is. But actually, flags in our case is codecs. Can be indexed. What? Hold on. Context should have like. Oh, this is not correct. So yeah, it should be like this. Vice versa. And this should be like this. Okay, and what is the error here? The type U8. Okay, slice indices are of type usize or range of usize. Yeah, as usize. Like this. No. Oh, yeah, so we also have to. Yeah. I guess to own should be not in this place, because it's also an error. Still we have errors. No, what is this? Oh, it's not red, so I expected to be an error. Yeah, so we have to convert to owned because we have these values. So under the reference, so payload. Yeah, I just forgot that we return a reference, and we have to return and just a copy of this to owned. And this is basically it. Oh, we don't need a return here. Okay, so now exec is never used. Sure. What is this? Field assembly. Yeah. So sorry for this, but we have to initialize it like this. But actually, since we have our new function, super useful new function, we can do like this. Context would be our vector with hello, and basically one, two, and codec would be just one. So since we don't have any codec, yeah, we don't need this. And now let's just try to compare with Go. So we don't need this. This was like our previous error. Command child stdio gorge error. Yeah, we do need a log here. Okay, but now how to count let mute timer is instant now, and let mute println done in and timer elapsed. Let it be seconds. And so let me do like this for in 0 to 1 2 3 4 5 6 like 1 million times. Let me see how much time Rust needs to be. So yeah, for sure we are running this inside an IDE. Yeah, so this is not a kind of super precise benchmark testing, but actually done in 9 seconds. Might be it's better would be to use a milliseconds. Cargo run. Cargo, let me test release. Boom, like the whole damn CPU is loaded. Why so long? src libres http. What? Okay, a cargo test, cargo specify test to run. Okay, so as expected. It's passed. So I know that it passed, but where is the result? So I know this in Rust as a test in release mode. Skip this println. How to actually return it? Okay, let's re-implement all the things in Go just to not waste time. Okay, we have this worker test in Go. actually. So let me do the same. Actually, the same. In Go, for sure, we have a a little bit more functions on these workers, on the things. So we have a buffer pools, so it can slow down, I guess, a little. We have test worker PHP, so let me just compare that we run the same worker. We don't need this would be test Go versus Rust, and I guess I've got this worker somewhere from here. It's like PSR, no. So let me just copy and paste in here. Worker Go bench. Let it go like this. So it's just so this worker doing only one thing. It's just receiving anything like you passed in to the worker via the pipes, and just responding with this payload to back. And worker Go bench, and we don't need all of this. We need to initialize this worker. We need to initialize our body and context with hello. Okay, so since we don't check errors in Rust, we're just unwrapping them. We are not going to do this in Go as well. Yeah, so finished in 571 is like the test finished in this amount of time. I guess we can like compare it to this result. Yeah, so it can be somewhere near the real result. So, but in case if we would have some kind of similar result in Go, so we would know that okay, so the results are somewhere on a par. We don't need this, and so assert no error. Let me just double check this, how it runs. Yeah, it runs fine, and response should be no, it should not be nil. Oh, worker, yeah. Go func worker wait. So we also have to start a worker. I guess it's not started here. Yeah, so cmd wait. Yeah. But in Rust we have new. Yeah, so in Rust we have slightly different behavior here. So the behavior differs in this spawn function. So in Go you just can't. You can start the process, but you have to wait this process just to not to produce a lot of zombies here, because you have to, like as I mentioned on the previous streams, you have to remove with wait for syscall. You have to remove child's entry from the process, from the parent process system table, process table. I'm sorry. And thus in Go we have this wait. Okay, now res we still have a 0. Let me just time sleep. Yeah, so okay, fatal. So but in Rust, so I didn't expect that we would have an errors. Result unwrap let res is equal to payload, So I'm putting foo here just to put a breakpoint on it. Yeah, result, context, body. Yeah, so we have a response. We are not responding with a context, but we're passing a context here. So responses are hello. Actually, we've got a correct response here. So, but let me do like. So Rust is more stable than Go at this point. So what is worker? Oh, let me double check. And spiral is decayed and tests. Composer update. So I know only one command, composer, and I know composer dump. I don't know why they need it for. I guess generating afterload files. I don't know what they are. And let's still panic. And why? So the process finished immediately. Do we have a oh yeah, we do. So I'm sorry guys, I forgot how it works. So we have to check first of all that there are no errors here, and we have used a worker start. Yeah, so error and require no error and error here. Yeah, so still panic. Are you joking? Still nil response. Okay, that's fine. What is this? Why starting with the debug produces an immediate error here? Okay, so let's remove wait. We actually don't need it here. Oh yeah, because I'm also stupid second time, because we are starting wait before we actually start our process. So if we wanted to use an wait, we actually need to use it here. Yeah, now everything's fine. But why we don't have anything in respond here? Body context. We have no error, and also we don't have anything to respond. Worker go, so everything here seems to be fine. So we don't need this. Not nil. Expect value not to be nil. Yeah, for sure. And why we? I don't know. Go. What's happened with you? Execute payload. So I guess we implemented all the thing faster in Rust than we're doing this in Go. I guess something we just not passed into our exec function. Let me double check. Okay, so 1, 2. Oh yeah. So Go is just too smart for us. So we have to worker. We have to we have to get our worker into the state, into the running state. where is this method? Do we have an access to this method directly from this state transition to FSM state ready? Boom. Okay. Once more time. Land body. Okay, state ready. Yeah, so I guess now it should be fine. So because in Go we have much more logic, I guess. Relay. Oh, God, we also have to attach in relay. Let me think how we can do this. Worker attach relay and relay new. IPC pipe factory. Actually, you know, we can use our factory here to allocate a worker with all of this kind of shit inside it. Yeah, let me do like this because this is too long to just use like naked worker here. And log r would be like zap new development require no error log here. And spawn worker with CMD. Boom, we don't need all of this, we don't need this. And worker and error. Like this. Should work now. Import cycle not allowed in tests. Okay, let's move our test out from this function to the pipes. And since we moved it out to the worker, so we also need to slightly update our command, because it would be like this, I guess. Couldn't open input file. More? Yeah. And finally we've got our response hello. Okay, so finally we did this. Now I'm just removing all of the things. We don't need to check response here, we don't need like this, and we just need to like dt time. So it's just like a very stupid benchmark, you know, but just to see our like first impressions, how it works, just like initially, you know. 4 is equals 0, e is less than 1, 2, 3, 4, 5, 6, e plus plus. And finally, let me use just fmt println. Lapse it. Let it be string times since dt and milliseconds. Oh, it should be like d. Okay, let's see. We also run in like in tests. Okay, so it's like without any optimizations, without anything. 7.43. Oh no, like it's like 6.4. So definitely not so big difference, you know. Just need to it's like 1.5 seconds difference between like, and let's use debug mode for Rust. Yeah, so debug mode is too slow. Yeah, 5.49, and here we have a 6.2 like seconds, like 6.3. I don't know, it's like less than second is between so it's quite surprising for me. It's like, so what we actually did, guys, I wrote some kind of half of the worker is our like process working with the PHP in Rust, and we have basically the same code in Rust and Go. So I just like rewrote all of these frames, all of this kind of low-level stuff into the Rust, and with all of this async await things, we still have so Go runs a little bit slower in less than a second. I mean slower less than a second than Rust. And this is quite surprising to me. So either Go so fast nowadays, or Rust is so slow. But you know, in Go we have a lot of like things that attach to this worker. So we have like a state machine, so we have to move between the states. We have a lot of like checks. So I guess when we implement all of the things in Rust, we will get basically the same performance than we have actually in Go. I guess the moral of this history is this is, I guess, I don't know. So PHP PHP is slow. The moral is PHP is slow because both Rust and Go runs PHP under the hood. So the moral here is PHP is slow. Actually, so it's quite surprising me. I expected that 1 million would be like, let's be like this. Hello Niham, welcome on the stream. Let's just increase our iterations from million to 10 millions and see. As you may see here, we don't have anything like, so all the process executed one by one, so we don't have any parallelism here. We don't have any worker pools, anything. We're just executing one by one. So basically that's it. I don't know, this is, so if this is, you know, the benchmark that shows something for us, so should we continue our writing in Rust, or so it's just like, okay, yeah, so Rust is supposed to be faster, but Rust is faster than Go in this case in less than a second in a million iteration. But so I guess this we are not comparing we are not comparing let me just 1, 2, 3, 4, 5, 6, 7. Yeah. Here we are not comparing the Rust and Go directly. So in just we are running PHP inside this process. So we are running PHP, which communicates with Rust and with Go via our protocol. So basically, the ballast here is PHP. So PHP is kind of slow, but with this delta, we can determine how fast can be like PHP in comparison with like our Go runtime, but in Rust. So how much we can save in Go somewhere, like optimize things, or I don't know. It's hard to say it. Let me just waiting for Go. Yeah, so Go is like 10 second, around 10 seconds, so 55 in Rust and 64 in Go. So it's like 10 seconds for 10 million iterations. Yeah. I expected it to be like 2 times. Like if we would have, for example, 2 seconds for Rust and 5. Yeah, but still we have a PHP under the hood. So why we're so... It should be like this, I guess. It should be something like this, because yeah, we have PHP under the hood. Yeah. Okay, so this won't stop me of to implement this all of the things in Rust, but so, and also remember that in Go we have much more things implemented. We have a finite state machine. We have a lot of different checks for the worker. We have a transitions between these finite state machine states. And I guess if we implement all of this kind of stuff in Rust, we would have quite the same time that we have in Go. And the only one reason to continue this writing in Rust is just to have like this fancy language. I don't know. Oh, yeah. So, but still, I like Rust more than Go. And oh, we have a development logger. Yeah, for sure, we should have a production logger here. So let's try to run in production mode. Yeah, this is. Oh yeah. So. Oh, no. So so we have this sleep for the second. Maybe we have something non-optimal in Rust, but yeah, so why I'm so like arguing about all of the things since we have a PHP under the hood. So it's still quite fast, 5 seconds for a million iterations for the PHP script, which uploads like a lot of things inside it. Like basically we have this script, but still it's a very basic answer. Like, okay, so that was quite surprising to me. I'm a little bit impressed by Go. So I do like Go, but I do like Rust more than Go. And yeah, 63 seconds. The same. I'm just thinking what can Rust offer us in this case. So first of all, we don't have all of our drivers, Rust counterparts for all of our drivers. So let me just double check. Do we have, for example, yes, I know we do have an SQS driver. We do have Kafka driver as far as... oh, no, we don't. Kafka Rust. I guess... so this is dead one, Kafka Rust. And I guess this is still alive. Yeah, I guess this is the dead one. Yeah, so last release was like 6 years ago, almost 7. But they have tags. I like this. Yeah. You're right. So Go saving PHP. So RoadRunner saves saving PHP and brings it to be much more faster. But at the same time, like PHP saves Go to be replaced by Rust. Yeah. Okay, so let me think what we are going to do next. So since we already implemented a lot of stuff related to the exec, we also have to implement exec with TTL. So it's like execution when user can limit the execution time of the script, and what is this? It was like a bucket of fresh water to me, like on my head, with this test. So I run it first time here on the stream, so I didn't know the results, and yeah, I definitely expected Rust to be much more faster here. With I guess Go spends a lot of time. So if we like if you think about only the process manager here, so Go uses a runtime. So I expect it to be for this runtime to be much more slower than it actually is. So actually, the runtime in Go, with all of this kind of garbage collection, you know, garbage collection runtime, like some kind of ugly types on a par with super clever Rust in this kind of stuff. I expected that Go spent a lot of time on sending a system calls like write or read from a process than Rust. I expected Rust to be like 2 times, 3 times faster than Go in this case. I'm sure that we can do like much more better tests, like compile Go binary, for example. If we compile Go binary in release mode, so it will be faster than 63 seconds that we actually have for 10 million iterations. So I expect it to be like, okay, so it would be like 60 seconds it only 7 seconds from Rust. So, and this is quite surprising for me. Like, actually, this is like a bucket of fresh water on my head. Okay, so but Rust, on the other hand, it's much more, I don't know. So it like when I work in Rust, when I rewrite all the thing in Rust, so Rust here is like so beautiful on a type system. So it's much more easier to develop in Rust. Even if we don't have everything at the moment implemented in Rust, for example, it takes some time to figure out how to implement a timeout, for example, in Rust, to time out a process, for example, to time out a process read, all of the things. So it takes some time to me to figure out how to like move these parts in from Go to Rust. But still, yeah, it's much like much better user experience from developer's perspective, you know. And also, I forget to do this.
First up, guys, you only need this ingredient.
Like data weight.
Then, and I'm going to take a nice centimeter slice.
Oh, we can do this. Yeah, and how we can, so in Go we have Go routine, yeah, but in Rust how we can do this? We can do like this.
Because you need it.
Please give me patterns here. But still it would be blocking function. So if we use unwrap here, it will block. And I guess we have to use a thread here. So, but yeah, so not thread, but actually Tokyo inside have some kind of lighter threads, like some kind of similar to Go routines under the hood. So we can definitely
Pretty good results, actually.
we can definitely use Tokyo like process, like not process. Where is it? Spawn, and let me check. Documentation not available. Thank you. Tokyo spawn. What we have inside? Future data weight. So something like this, and future would be with a weight, but we also no, we can do this. We should have a future. Yeah, it's not a future. Actually, future produces our weight function. No, data. What produces future here? Tokyo spawn. Let me check the documentation. Yeah, so they have we can't actually move it like with async move, so they like they move in this function. But yeah, so as you can see here, we can do this because value borrowed here, so we can't like we can do move. Maybe we can do just async. No. Yeah. So that's interesting how we can do this. So basically what I need to do, so wait function should be started in a different routine, like we like this, for example, go func and where's the worker wait. So this is not safe. So in Go you can do this, but this is not safe because actually worker here can be nil. So we just like moving this worker from this field of vision to this to inside the Go function. So like having like a callback, for example, here, and we just can't. So in Rust we are doing practically the same, but Rust arguing us that okay, so you can do this because the value moved here is also used here, so you can't use the data like at this point because you moved it. But we have to start wait before we actually execute any payload. Why? Because wait function actually it's not start anything, it just calls just calls wait for system call just to clean up like parent process descriptor, and we can do like this for sure. After we execute payload we can do like this, but since we don't have we can't like parse, so we're in a test, so we should use like this. So we can do this actually without any like Go routine. But in Go, as you may see here, what I have this nice I have this nice allocate function which doing everything, like not this one, I guess this one, we're doing everything for me, like start, skills, everything, collaborate with the like PHP process, and actually I don't see wait here, so wait used out of this function. Let's check the documentation. So documentation should answer on all of our questions. Reference counter. So can we use actually reference counter here? So yeah, so we can't use move here for sure because we are using data here out of this. So we can use, I guess, reference count because we have two types of functions, send and sync. So send functions are safe to pass like this, like we passing here, and sync are safe to, if they implement sync, they safe to be in different threads, like send and sync Rust. Yeah, so I'm sorry, send is safe to send to another thread, and sync is safe to share between threads. So basically, what is the difference here? So send is actually our like this async move. So when we are moving to a different thread, but sync in our case we can basically use. So in this scope, like with like this async, and use the same, like let's say, structure in a different thread. Like for example, we have in Go, we don't have any similar concept concept in Go actually, but we have a, for example, mutex, and if we share some kind of structure between the threads, we have like actually this sync implemented, like Rust sync. I don't know. So we can't implement them because they are unsafe. Yeah. Oh yeah. So we can do. So we need to implement sync. Okay, ChatGPT, this is time to shine. We need to use object, let's say in the Tokyo spawn, and outside of it, what trade should we implement on that object? Send or sync? Send and sync. Oh, so unexpected to hear this. Yeah, we should implement send and sync. Okay, ChatGPT, that was helpful. So we have to implement send for worker process. And this is unsafe. Unsafe into sync for worker process. Nice implementation. Like the same as mine. Actually, quite the same. Okay, so and data wait. Wait. Still no. Well, borrowed here after move. Yeah. Oh. So, like this. So I definitely need to read a book about this. But we have a book about this. Rust programming language. Let's see what's inside. Okay, so smart pointers, more about cargo, full pointers, running. Fearless concurrency. Fearless. Yeah, I'm getting into fear every time when I have to deal with the Rust concurrency. So we have to learn this definitely. Okay. Use thread decode. So and this is like, okay, thread spawn for I in 1 to 10. Fearless concurrency. Using these samples, yeah, for sure, there are no fear to use some samples like this. Waiting using move closures with threads. Okay. Thread spawn, yeah, so this is my outlive. Okay, so where is it? closure might leave. Yeah, so this is very clear example. So yeah, mayout leave, thread spawn, closure. Yeah, we have to add move, but so I'm doing so. This is because it's so hard to like design everything in Rust. So maybe it's just like only when I don't know how to design everything in Rust. So how I can okay, thread std thread spawn, and we're going to use data weight here. Closure mayout leave, exactly the same error message like here. Mayout leave b borrowed by value of b. Okay, and we have to add magical move. Cannot return reference to like this, and make lambda async. Async closures are unstable. Make lambda async. Okay, async is unstable. Goodbye. Okay. Yeah, so I know that async are unstable. Rust load asterisk spam. So these samples are too easy. Like, you know, println, here's a vector. But I guess we should get a idea using messages passing to transfer data between. Yeah, so yeah, and also one thing in Rust, that also in Rust we have channels like in Go, but in Rust actually we have so if in Go we have only one kind of like channel, so we can send or receive to this channel with the like arrow operation, like channel like this, for example, or read from the channel like this. So in Go, I'm sorry, in Rust we have like separate receiver part and sender part. So this is kind of fun to have like these two ends of the pipe. So yeah, we can use the channels, but this is yeah, we can send this. So basically I'm interested in a thing like this. So as you can see here, channel here used as an outside value, you know. So let txrx channel, and move also uses this channel here, send, but they like don't use this like tx after this thread. So I guess this is my Go experience forces me to use like this. I don't know. Channels and ownership transfers. Might be just so. This is just a wrong like smelling design of this feature. So this function will block. until it exits. So so yeah, basically mutexes are basically the same as we have in Go. Yeah, so basically the same as we have in Go. Yeah, for sure, if we if we try to use the same variable with inside different threads, so yeah, that would be an issue. Might be we need to, I don't know, somehow clone it with RC, but inside the reference counter you can clone this some kind of mutexes, but not the whole object like I'm using here. Okay, let's just try. Let's clone. Oh, future can yeah. Cannot be sent between threads safely. Future can async blocking send. Yeah. Okay. RRC. Like atomic reference counter. Yeah. Where is it? Arc. Yeah. Arc new. Can borrow the atomic reference count as mutable. Oh, we don't need this. Can we do like this? Data, wait, await. Yeah, we can do like this. I think move, await. So this will like spawn a thread. Not thread actually, but actually this is as far as I remember, Tokyo spawns their own workers. So they are not the same as threads, but I need to double check this. But after this, I can't use this execution because we are using a moved value here. We can't use even clone. might be we need to put all of this kind of stuff into the mutex. Let who is equal to atomic reference counter new mutex. Oh, do we have an RC also in? No, we don't. In Tokyo, mutex new data like this, and let's. Okay, so we're going to use foo clone and oh, this is also future. Okay, and let data is equal, but we should also unlock it, do we? Oh, it will be unlocked, yeah, when they will go out of the scope, I guess, yeah? Oh, when await, yeah, so when await call would be finished. But in this case, so I guess in this case, I guess we have to also. So it will be locked for indefinite amount of time. So it will be locked without unlock at all. It will spawn on different thread, you know, and locked forever. And we can't use it here, so we have to use some kind of read lock. Okay, guys, I need to read a book a little to figure out how to deal with all of this code, but this is definitely looks like a fight with the compiler, as like everyone told about Rust. So you have to fight with the compiler. So in easy cases, when you have here in like a book, this is like very easy to figure out how to deal with this. So if we have a like shared variable, we just need to use atomic reference counter and a mutex here. But since we're unlocking it here, we can definitely use the result here without any problems. But in our case, we're not going to unlock at all. We will be locked like here until the process exited. And since we are waiting on this wait call, we we are need to use this execution, this exec function, and this might be some point of intermutability pattern. I don't know, so I need to double check this. But while we are using this child, actually, which would be blocked until we exit from the process, we should be able to use the same where is it? The same pipes and send and child process to send the payloads to a worker. And in case of Go, this is unsafe, but very easy to achieve. In case of Go, it's unsafe. So because as you may see here, in case of Go, we just can start the process. We can start it also with spawn. This is start is equivalent for spawn in Rust. We can spawn it and without any problems. So, and then when we run everything in production, we can this was an error. But in Rust, we have to fight with the compiler until we figure out how to do this. And as you may see, in case of Go, we can do like this. This is not a good approach because this W here might be nil, for example. This wait function, so this definitely doesn't mean that this function gofunc will run right in this place of code, like right here. So it can be executed after this function or after this or here, for example. And that is why Rust is arguing us that okay man, this is not safe to use constructions like this. You just can't use at the same time. You can't just use a data and call wait starting a thread and at the same time use this exactly the same data to execute a payloads. You just can't do this. And Rust clearly states about this. So because it's okay, so if you want, so will abort here after move. And in Go, this is exactly the same pattern as you see here. So actually, under the hood, we're just moving this into our Go-routine stack here. Not moving, but yeah, so this is kind of similar. And Rust okay man, so this is kind of shitty code. And in Go here, for example, if we would be if some error occurred here in our command, and command will be nil, and we start our pipe factory, start everything, and at the same time until we starting all of the things, we execute this wait would be executed inside this our routine. That would be a problem. It will be nil pointer exception, actually. And Rust saves us from this pattern. And while I code everything in a Go style, so I have this error, and I need to figure out. So I guess the intermutability pattern would fit nice here, and I need to read a little bit about this pattern, so it's not so fun to see how I'm reading. And yeah, so guys, I guess on the next stream I will be a little bit more prepared to this situation. I'll try to explain how to deal with such kind of things. I need to read a little bit this kind of book. I don't think that I can read it on stream because Amazon can shoot me, can sue me. I don't know if this can happen, but I don't know. So if it's legal to read Amazon books on the streams. Actually, I think it's not legal. Okay, guys. So have a great evening, and as usual, see you tomorrow on the same time. And bye bye.